Okay, this is a recording of the Mod 1 Learning Target Review, and this is part 1. Okay, so the first thing is I can evaluate expressions, and we are going to get started. So for number 1, I want to find h of 2. So that means I need to come up here to the h function, and anywhere I see an n, I'm going to put a 2. So negative 2 times 2 plus 1. And you can use your calculator. Get negative 3. Next, I have p of 3. That means I'm going to come up here to the p function. And anywhere I see an n, I'm going to put a 3. So negative 2 times 3 to the n, which is 3. So that's negative 2 times 27. So the answer is negative 54. Problem 3, h of negative 4. So now again, I'm going to come back up to this h function, and anywhere I see an n, I'm going to put a negative 4. So negative 2 times negative 4 plus 1. Negative and a negative is a positive 8 plus 1. So my answer is 9. All right. My next learning target is I can write equivalent forms of exponential relations. All right, so for problem number 4, I have negative 9 times 9 to the 4th. And the thing to note here is this exponent of 4 is on the 9. It is not on the negative. So this is really negative 1 times 9 times 9 times 9 times 9. Number 5, 8 times 2 to the 3rd power. So 8 only has an exponent of 1. 2 has an exponent of 3. So times 2 times 2 times 2. Problem number 6. The whole quantity negative 5 is being squared. That means all of negative 5 is being squared. Okay. Next, I can identify the common difference for an arithmetic sequence, or I can identify the common ratio for a geometric sequence. All right, so really for this, you have to kind of look at the pattern, see if you recognize one, and then test and make sure that you're correct. So I am looking at how 5 goes to 11, 11 goes to 17, 17 goes to 23. If I subtract 11 minus 5, that gives me 6. 17 minus 11, that gives me 6. 23 minus 17, that gives me 6. So I'm going to say my common difference is 6. I am consistently adding 6 to each term. All right, number 8, when I look at this, I notice it's going down. I know it's arithmetic, so that means I am subtracting. So how am I going from the first term to the second term? I subtracted 4. Let's see if that holds up. 3 to negative 1, I also subtracted 4. So I'm going to say my common difference is negative 4. All right, now I've got some fractions here. Again, I know this is arithmetic, and it appears to be getting larger, which means I am adding a number. So I'm going from 2/3 to 4/3. Well, how far apart are those? I'm going to subtract. 4/3 minus 2/3 is 2/3. So what that means is I am increasing by 2/3 every time. All right, now in my geometric sequence, I'm not sure if you noticed, there's a typo. This should say common ratio. So you can fix that. Common ratio. All right, so I know that I am either multiplying or dividing by a number to get to the next term. So what could I multiply by to go from 4 to 20? Well, I can check that by doing 20 divided by 4, which I know is 5. Let's check and make sure that's true. Is 20 times 5 100? Yes, so my common ratio is 5. Number 11. Again, this is a geometric sequence, so I know that I need to either multiply or divide by a number. I am getting larger in my sequence, so I know I'm going to multiply. So I'm going to take the second term, divide it by the first term. I get -3. And then I'm going to check and make sure that works. So does 24 times -3 give me -72? Yes. So my common ratio is -3. All right, in problem number 12, I see my sequence is decreasing. I know it's geometric, so that means I must be either dividing or multiplying by a fraction. And I see some fractions. So I'm looking here. I know that to go from 1 to 1/3, that means I must have multiplied by 1/3. So I'm going to check, is that true here? 3 to 1, am I multiplying by 1/3? Yes. So 1/3 is my common ratio. Now, I can generate the missing terms of a geometric or arithmetic sequence. Same strategy as before. The only difference here is I have to decide, is it arithmetic or is it geometric? Well, this pattern looks pretty easy. 5, 10, 15. I am assuming my next pattern then is going to be 20 and 25, making this arithmetic because I'm adding 5 each time. 14, I'm decreasing, so I'm subtracting 6. So I've got 12 and then 6. All right, 15, let's see, I've got a +3, +3, looks like that continues. 8 plus 3 would be 11. 11 plus 3 would be 14. Perfect. 17. Problem number 16, I'm decreasing 20 to 10. Now, that could mean that I'm subtracting by 10, but then if that was true, my next value would be 0. So then this 2.5 would not make sense. So another thing to consider would be I'm dividing by 2. So if I divide by 2, that would give me 10. So if I divide 10 by 2, I'd get 5. 5 divided by 2 is 2.5. Yep, that works. 2.5 divided by 2 is 1.25.